Hello everyone, I'm Sangmin Park from the Department of Orthopedic Surgery at Seoul National University Bundang Hospital, and I'll be presenting on AI programming today. Artificial intelligence is currently being integrated into numerous fields and has the potential to replace humans in many areas. While it was once believed that AI would not replace creative work, it is now most actively replacing humans in creative fields, including art, video, music, and writing. The research you've seen so far has primarily focused on models specialized in image analysis. Now I'll discuss large language models, LLMs, like ChatGPT. As you can see, LLMs have evolved tremendously, with the number of parameters increasing exponentially from the BERT model to GPT-4. The most important fundamental principle of LLMs is predicting the next word. For example, after "in the blue sky," it predicts that words like cloud or airplane are likely to come next. Since LLMs are prediction models, there is always a possibility of generating incorrect information, known as hallucination, in areas where they haven't been trained. Currently, there are several representative LLMs in the market, including OpenAI's ChatGPT, Anthropic's Claude, and Google's Gemini. Recently, powerful models like DeepSeek have also emerged as open source, allowing anyone to use them. To maximize LLM performance for specific purposes, you can utilize technologies called fine-tuning and RAG. Fine-tuning involves additional training of the model, while RAG, retrieval augmented generation, is a technology that references external databases to generate responses. In particular, using RAG can significantly reduce hallucination, which is the biggest drawback of LLMs. By running models locally, data doesn't get transmitted externally, making it safe, but it requires high-performance graphics cards or computers. The most recommended local program is LM Studio, which allows you to download and use most of the latest models. Comparing the latest models GPT-5 and Claude 4.5 Sonnet, personally, GPT-5 excels in most tasks such as data analysis and statistical processing. On the other hand, Claude shows greater strengths in creative writing and coding. If you have to choose only one, I recommend GPT-5 for its versatility. How far has AI's programming performance come? On the SWE bench, which evaluates the ability to solve problems in real development environments, the latest AI model scored over 70%. This is comparable to experienced top 10% professional developers, meaning they can solve very complex engineering problems. Recently, AI capabilities have been deeply integrated into coding programs like VS Code and Cursor. What matters more than which program you use is which AI model the program is based on. Currently, many programs are adopting the Claude Sonnet model, which has strengths in coding. Recently, the concept of AI coding agents has emerged, taking things a step further. Models like Anthropic's Claude Code, OpenAI's Codex, and Google's Jules are representative examples. Beyond simply generating code, they have the capability to autonomously check the codebase in terminal or cloud environments, modify it, and even handle testing. This screen shows the actual AI coding agent, Claude Code, in action. As you can see, when the user requests implement a coffee ordering prototype, the agent understands the project structure, asks whether to create necessary files, and then writes the code directly. We're entering an era where such complex development tasks can be performed autonomously. We typically collect research data by receiving paper questionnaires like these from patients. The collected questionnaires are then checked by research staff and manually entered into Excel files or databases like REDCap, as you can see here. This manual approach has several clear problems. First, it requires significant time and labor costs for research staff. Also, since it's human work, errors occur more frequently than expected due to decreased concentration or drowsiness during data entry. Therefore, it's very important to automate such simple, repetitive tasks to save labor costs and reduce error rates. To solve this problem, I directly developed a program called Clinical Questionnaire PDF Processor. This program is a system that, when you upload clinical questionnaires in PDF format, automatically extracts data by selecting AI models like Claude or GPT and converts the results into CSV files. I published research results using this program in the Journal of Korean Society of Spine Surgery. After analyzing 56 questionnaires, the Claude model showed very high accuracy of 96.76%, and processing time was greatly reduced to about 27 seconds, one-third of manual work. With recent models, accuracy has improved to 98%, achieving nearly perfect processing except for handwriting. This automation system can be applied to other fields beyond the spine. What you see on the screen is the interface of the Auto Shoulder Survey program I created to automatically process shoulder joint questionnaires. Similarly, it's a system that converts questionnaires into CSV files and can directly input them into Excel files.
Going one step further, I developed a tool that automatically analyzes conversations between doctors and patients to generate medical records and PROs. This system receives audio files as input, converts them to text, and the LLM service analyzes the content to generate the final output.
This is the actual results screen. When you upload an audio file of a conversation with a patient, the AI analyzes the conversation content and automatically organizes it into medical record format, as you can see, from chief complaint to history of present illness and past medical history. Furthermore, based on the patient's responses, it automatically calculates patient-reported outcome measures, PROM scores, such as VAS for pain, EQ-5D for quality of life, and ODI for lumbar function disability index, creating quantitative data. I'm conducting research on segmenting spinal endoscopy images, and I've created and using an automatic segmentation program using the Segment Anything model. Although I'm still learning and the performance isn't great yet, I've trained it to some extent and achieved relatively decent results. I'll study this further and present good results in the future. LLMs can be very useful not only for creating programs that can be used in actual clinical practice, but also for coding research data analysis, for writing papers. Everything from logistic regression analysis to complex machine learning techniques like XGBoost can be implemented. However, you shouldn't simply ask AI to do statistical analysis. Researchers must first thoroughly analyze prior studies according to their research purpose, judge which statistical methods are most appropriate themselves, and then use AI to obtain meaningful results. Once the appropriate statistical method is determined, you can then receive AI's help. For example, if you request write Python code to compare logistic regression, random forest, and XGBoost models to predict clinical outcomes after surgery, it will instantly generate complex machine learning pipeline code, as you can see. When you run the generated code, you can easily obtain results like ROC curve graphs that allow you to compare the performance of each machine learning model at a glance. This allows you to intuitively understand which model is superior in predicting specific outcomes. Writing a meta-analysis paper requires a long time and effort, but I've also created and am running a program that can automate this to some extent. It can dramatically reduce the time people spend reviewing papers. When you run the program, 3 LLM programs each review and analyze each paper, and we just need to briefly check them. You can also easily convert what needs to be checked into an Excel file. To summarize today's presentation, first, various LLM models like ChatGPT, Claude, and Gemini each have distinct strengths. Second, AI coding performance has already reached the level of top 10% professional developers. Third, we've seen practical applications of LLMs in medical research. Finally, the most important point is that by utilizing LLMs, anyone can now easily do programming. You don't need to be an expert programmer anymore. With AI assistants, doctors and researchers can create their own tools and automate their workflows without extensive coding knowledge.
Thank you for listening.